Hi everyone, we are the Systems Engineering Senior Design Group presenting a conceptual evaluation of CryoMag's sustainable operational usage in collaboration with NASA. Systems engineering is an interdisciplinary and integrative approach to enable and guide the successful use of complex engineered systems using systems principles and concepts. SysML, Systems Modeling Language, is a system architecture modeling language for systems engineering applications. It supports the specification, analysis, design, verification, and validation of a broad range of systems.
For this project, we have partnered with NASA's Johnson Space Center to identify and quantify shortfalls in space exploration, from launch into orbit to re-entry into the atmosphere. Unlike typical senior design projects, we were not given a set-in-stone project definition or problem to solve. This resulted in the team spending the first 5 weeks of the semester identifying gaps and brainstorming possible solutions in many aspects of space travel. After multiple meetings with the team at NASA, we decided on mitigating lunar regolith. Lunar regolith is a fragmented, sharp rock material found on the surface of the moon. It is extremely abrasive, electrostatically charged, and particles can be fine as 10 microns. Once we settled on our topic of mitigating lunar regolith, we next had to identify the system boundary. The definition of the boundary took us quite a while, but we eventually determined that we wanted to base this project on the cryogenic magnetically latching coupler, CryoMag for short, a system designed to use on the lunar surface to transfer liquid fuel. To achieve this, we have heavily relied on two SysML applications, Stella Architect and Magic Draw within CATIA. Stella is a comprehensive, high-level modeling and simulation software that can be used to analyze and publish dynamic system models. In this software, we modeled numerous qualities of the CryoMag, including mating resistance, connector temperatures, material dimensions versus temperature, and expected wear based on regolith simulant makeup and particle size. Magic Draw is a system definition and modeling platform that allows traceability across multiple domains, specifically stakeholders, requirements, activities, and the system structure. In this platform, we have modeled different use cases to represent our requirements, determine how our system is satisfying a specific requirement, and visualize the different relationship and interactions within the system boundary. Through the use of these softwares, we have created a beginning framework to help future teams set and test requirements for the CryoMag. Throughout this project, we have also developed different deliverables to assist us in the creation of the framework. We created a house of quality, an FMEA, and a large requirements spreadsheet. The HOQ was used to pinpoint what type of connector we wanted to focus on, mechanical, electrical, or thermal. This allowed us to review both the technical specifications and customer requirements. Using an FMEA, we identified over 30 risks concerning the CryoMag and then integrated them into the SysML model. We also created a requirement sheet to help us identify stakeholder requirements for the engineering, design, and manufacturing of the coupler, as well as some requirements that could be implemented into future versions of the CryoMag.
Overall, our senior design project is a unique approach for problem solving. We were able to apply our systems engineering skills to create a framework for a problem we identified within our very large scope. This project would not have been possible without the hard work and dedication of the folks at NASA. A big thank you to Katie, Bill, Thomas, and Jonathan, as well as all the teams at JSC that joined our meetings throughout the semester. We would like to also sincerely thank our faculty advisor, James Bittner, our external advisor, Robin McCullough, and the Incosi, Michigan chapter, as well as the faculty and organizations at MTU that helped us along the way.